Alright, welcome to my video on properties of logarithms. Now I have a couple of different parts to this video series, so you're going to see this introduction is going to be the same for all of the logarithm problems, but I did want you to understand a couple of things. First is that logarithms are really nothing more than an alternative way to keep track of exponents. Now sometimes I refer to logarithms as like the land of the logs, okay, like a totally different universe or a totally different country. Okay, the rules, they're kind of similar, but they're also kind of different. Okay, so I want you to pay attention to those differences. For example, when you were dealing with exponents, right, and you were multiplying two terms, like if you were multiplying x times x, that gave you x squared. Now that was like saying x to the first times x to the first, and then taking 1 plus 1 and adding them to make 2, giving you x squared. So I want you to pay attention to logarithms in the same way because they have a lot in common with the rules for exponents. Okay, so just pay attention to that. Addition, kind of like multiplication, and subtraction, kind of like division, so look for those similarities. Now, the final thing I'm going to leave you with is there are some additional tricky rules, okay, that come with this because you're going to need to be fluent in converting between what they call logarithmic notation and exponential notation. So I want you to pay attention to those times where you're flipping between the two. And I want you to also pay attention to things like the bump rule, where you're actually converting between exponential and logarithmic notation, and also some of the other fun rules like the change of base rule and what's another one? There's one that also has like where the log of a number to that same base, like for example log of 10 to base 10. Alright, paying attention to those kinds of situations and what they mean. So there's a lot of different properties that you're going to learn about, and I want you to just get what you get from each part and just keep practicing is my best advice, okay? Stop the video when you need to, go back and practice, and I'm very sure that you too will be able to navigate through the land of the logs. All right, here we go. So here we go. We got some logarithms here. I'm going to show you some properties of logs. This is part one of a three-part series on the properties of logs. I'm going to show you every trick that I know for logarithms, and I'll take you through a series of problems. You can download the worksheets from the website as well if you want to practice along with me. All right, and at any point if you want to stop me, just hit the pause button. I may go a little fast for some of you, but don't let that intimidate you. Just slow me down by hitting the pause button. All right, let's take a look. First set of problems involves rewriting each equation in exponential form. So here we have log to the base 6 of 36 equals 2. Now when you rewrite this, imagine that the 6 is bumping into this 2 here and raising it up. So the 6 collides with the 2 and bumps it up. And then set that equal to 36. And that's how you write an equation that was in logarithmic form into something that's now in exponential form. All right, so this exponential form looks like that, okay? Because we have exponents. See, that's why it's exponential form. You get it? Exponential form, exponents. All right, let's take a look at the other one here. If we apply that same rule, we take that 3, bump up the 4. There you have it, okay? 3 bumps up the 4. This equals 81. Now you have this problem in exponential form. All right, pretty simple so far. It takes some practice in order to get it down cold where you can do this without even thinking about it. All right, now that we've done the bump rule and we've tried this out, let's do another set of problems, but we're going to go in the opposite direction now. We're going to take something that's in exponential form, we're going to rewrite it in logarithmic form. How do you do that? Well, it's kind of like the opposite of when we were bumping into these numbers here. We're actually going to separate these two numbers. So we're going to write this as log to the base 12 is going to be equal to 2, right? Because these two guys need to be separated. And then you're going to put 144 right in between. So this is the same expression rewritten in a logarithmic form. All right? Let's take it to the abstract place now. We're going to use letters instead of numbers. God, I know how much you love that. All right, so here we go. Let's write log. We're going to separate the base. Here's B. We're going to separate the A. We're going to put the A over here, right? So you got to keep them separated. All right, I think there's a song that sounds like that, right? Keep them separated. All right, then you're going to put the 120 in the middle. And now you have your answer. Log to the base B of 120 is equal to A, and you're done. All right, that's pretty cool. Let's try one more abstract problem here with letters. We're going to separate these guys. So we're going to write log 8, and then we're going to put the Y over here. And now that we've separated these guys, we'll put our X in the middle, and we're done with that part. Okay. Now, we're on to something a little bit tricky here. I know it always looks ugly, but just follow the same steps. Don't freak out, please, okay? Everybody freaks out with the fractions. I just don't know why. All right, anyway, we're going to separate. What are we going to do? That's right, we're going to separate. So first, let's take the log base 4. We're going to separate that negative 2 over there. And then I'm going to put that 1/16 in the middle and just put parentheses around it just to be sure that this guy's by itself. Okay? So that's a way that we can rewrite the expression using logarithms there. All right. So those are the first couple of examples. I got 2 more for you on this page. And here we're going to rewrite the equation back into exponential form. So we're going to finish the way that we started off. Okay? So what do? That's right, we're going to do the bump rule. We're going to put this up here. So we'll take 64 to the 4th power is equal to x. And we could actually solve this if we wanted to. Let's go ahead and do that. So I'm going to turn on my calculator, make sure it's all clear. Now, in order to solve a problem like this, you need a special key. And I'm looking for that key right now to see if it's on here. And it is the one that raises x to the power of y. Let's see. Does anybody find that key before I do? Let's see. For some reason, I'm having trouble locating it. Let's see. Where are you? I know you're here. You can run, but you can't hide. Let's see. Wow. I guess this would be under a special menu then, huh? All right, well, let's see if we can find it. I'm just feeling adventurous. So we can take a look at the math that we have here. There's a lot of different functions available. You can take cube roots of things. You can raise things to different powers if you wish. They have some abbreviations. So it looks like it's not in this menu. That's kind of strange. All right, let's see if we can figure out something else with this. Well, I guess I'll have to find that for you and solve it out next time. If you really wanted to figure it out in the shortcut way, I guess you could just raise 64 to the 4th power like that. The little caret symbol here means that you're raising it to the 4th power. I thought there was some special key, but apparently there isn't. Wow, that's a big number. Okay, so x could be equal to 16777,216. Wow, so if we were solving this out, that would be a really big number. Okay, now that we had that conversation, let's go over here. Okay, we've got 8. We're going to bump this up, raise it to the 3rd power. That's going to be our x. Let's try 8 raised to the 3rd power over here. And x is equal to 512. All right, well, that's part 1. So we did a couple of properties of logs for you and solved out and converted between exponential form and logarithmic form. And we even took it to a new level where I'm showing you how to even solve equations that involve logarithms. So take it slow, practice a lot of problems until you feel confident that you can flip between these two forms, and then when you get to your algebra, it'll be a lot easier to solve the algebra. Alright, that's it for now. Watch the next video if you need some more advice. I'll see you next time. Okay, you just got done watching a video on the properties of logarithms, so hopefully your logarithm kung fu is a little bit stronger than it was before. And all I can emphasize at the end of these videos is practice. Practice, practice until you know it in a way that you don't even have to think about it, okay? A lot of these rules are not natural, okay? Things like the change of base rule and the bump rule, and even simple operations that you'd think, oh, okay, I'm just going to add these logs together, and then it turns out, hey, why am I multiplying these things, right? So there's a lot of rules that are kind of like a little different with logarithms, and you really do need to practice them in order to get better. So be sure that you get really good at converting between logarithmic notation and exponential notation. Make sure that you're becoming familiar with all those special rules, right? The bump rule and those kinds of things. And then finally, just keep practicing, okay? You're not going to get better overnight. Just give yourself some slack, right? Give yourself some patience. Be patient with yourself, and then just practice. And I'm sure you're going to be good at this in no time. All right. Good luck, and if you need more help, watch another video.